Listen, thank you for yesterday. You really helped me with that first step of that common factoring. I took some of the problems home and I reworked some of them to make sure I knew what I was doing, and I feel like I'm ready for this second block, if you call it block. I guess it's the next step.
Right. You have to remember that this is the second step in the greatest common factor technique, and that there was an introduction in block 1. So if at any time when you're seeing this tape, if you feel that there's a gap or something missing, it might be because you didn't view the tape for block 1, and you could always stop this tape and go back and watch block 1. But for those of you who feel that this is the point where you need some help, this is the second step in the greatest common factor technique. What you want to do now is just imagine that you are this student, that you're responding to the questions, that you're doing the work, you're using the booklet that you have to work along with us whenever the directions are to work with the pencil and paper. So now, as long as you have practice at home, what you might want to do now is look over a problem that's somewhat similar to what you're used to, but it'll have a little different slant because we're going to go one step forward. Again, whether or not the directions are written out, whenever you need this technique, you want to factor, you want to change to a multiplication format. Parentheses, symbol of operation. Ask yourself the same question.
Okay, so I'm looking for something that will divide both the 6A and the 18 evenly without remainder. Okay. And 2 divides both.
Right. So you would consider 2 to be your common factor, positioning it in front to indicate the multiplication. Then by your division technique, 6A divided by 2 is?
Okay, that would be 3A.
And for your second position, the 18 divided by 2 is?
That'll give me 9 for the second.
Then, if you wanted to check it by your distributive law and you multiplied out, the 2 times the 3A would give you 6A, adding 2 times the 9 would give you 18.
And that's what I started with.
But here, since it is the second step, it's a little bit more advanced. Before you actually do that multiplication check, look inside the parentheses and see if this were a problem all by itself, the 3A plus 9, could you find a common factor for those 2 terms?
Yeah, 3 still divides both of those.
Right, so although you have picked a common factor, you haven't picked the greatest. And that's what we always expect. Even though the directions might only say factor, it's understood to mean that you want the greatest or largest common factor. So now you said that inside these parentheses there was still a 3 factor.
Right.
You had already recognized the 2 factor, and since factor means multiply, the 3 times 2 would give you 6. And then your greatest common factor for this particular problem is going to be 6.
That's right, 'cause 6 does just divide both of those, that's right.
So what would you have left for your first position if you divide by 6?
Okay, 6 into 6A will leave just 1A, and I'll just write A. And then 6 into the 18 will leave the factor of 2.
3.
Oh, I'm sorry, 3, that's right.
Right. And now, ask yourself that same question. Inside the parentheses, is there anything common to those 2 terms?
No.
And that's a check as to whether or not you've gotten the largest factor out. Then when you do your multiplication check, 6 times A is 6A, adding 6 times 3 is 18. That checks your addition.
Okay.
Well, your addition, your multiplication, any arithmetic operation you're doing.
Mm-hmm.
And now this gives you the right answer. So this is the proper one because you've selected the greatest common factor. If you look at 30 minus 12A with your format and symbol of operation, ask yourself the question, is there something that will divide 30 and 12A? But then go that extra step. Have you selected the largest number that will divide?
Okay, when I first looked at it, I think of 2.
Which is common, but is it the largest?
It looks like 6 again divides both of those. So.
Right. Yes. It's 6 again. So if you take 6, 30 divided by 6 will be 5.
Right.
12A divided by 6 is?
Okay, that'd be 2A.
And can you tell me now if you have selected the largest common factor?
Okay, now this time there's nothing else that will divide out, so I must have gotten, is that the idea, I've gotten the largest out?
Right. That first internal check, looking inside the parentheses, and if there's nothing common, then you know you have the largest. Then by covering and actually doing the distributive law check, you can find out whether or not you've made a small mistake. 6 times 5 is 30. And subtracting 6 times 2a is 12a. Comparison shows me that I've at least done my operations correctly. What would you say would be the common factor, the greatest common factor here for 8a plus 2?
I always get nervous because I'm afraid I'll get the biggest one. Looks like it's just 2.
Right. And then by your division, 8a divided by 2 for the first blank would be?
Okay, that'd be 4a.
And 2 divided by 2 for the second position?
Okay, 2 into 2.
All right, go ahead. Your division answer would be?
It'd be 1, I think.
And sometimes people have a tendency to leave that out because they think that
It
it's
looks
not
funny.
important, but it's
Not used to doing
necessary. Let's do our first check and then find out why it's so necessary. The 4a and the 1, do they have any common factor?
No.
So you're sure that even though 2 is a small number, it is the largest factor that will divide both of them. Now here's where that becomes extra important. 2 times the 4a is 8a, adding. If you didn't have that 1 there, when you multiplied 2 times something, to get back the 2 you started with, you have to have that identity element. So if you can remember that, I don't think you'll have too much trouble. I've done, along with you, these 3, but if you take this booklet and turn to page 2, you'll find just a blank sheet of paper, and this is purposely put there for you to do your work. So if I give you the problem, just copy the problem and work it as we work through it. And the first problem you want to copy is 20x minus 30. 20x subtract 30. And for your format, your parentheses and symbol of operation.
Okay, the parentheses to show I'm doing multiplication and the subtraction operation.
And now you say to yourself, is there something that will divide 20x and the 30? And then stop before you write it down and make sure you've got the largest.
Okay. The fact they're both even, I think of 2, and the 10 clues me in that the zeros here give me a 5, and I put that together and I think about a 10 would be the biggest thing I can think of.
It will be. And sometimes you might have to do the problem twice to make sure you've got the right answer, but that's the greatest common factor.
So I'm going to divide each of the terms by 10 and see what's left for each term. Okay, so if I divide 10 into 20x, that's going to leave me with a factor of 2x.
Right.
And if I divide 10 into 30, that'll leave me with a factor of 3. Okay.
I just cover this up so your eye will only be looking inside the parentheses. Now to check that you've got the largest, can you find a common factor for the 2x and the 3?
No.
Okay, that should guarantee you that you've got the largest common factor. Now go ahead and do your distributive multiplication check.
Okay, multiplying back through, 10 times 2x will be 20x, minus 10 times 3 will be 30. And that should be what I started with. And it is. Good.
Why don't you try 14a minus 7?
Okay, 14a minus 7. That's right.
And go ahead and put your parentheses and subtraction symbol. Ask yourself the same question. Is there a common factor for 14a and the 7? If so, make sure you choose the largest.
Okay, it looks just like it's 7, which isn't very large, but that's one thing I know that divides both the 14a and the 7. Okay, if I divide that out, that'll leave me with a factor of 2a for the first term. And it divides 7 into 7 here. Okay, that's that
The same
1 again.
one.
Okay. Okay. Yeah, okay.
Now you tell me, what's the first check to make sure you have the greatest common factor?
Okay, there's 2 checks, is that right? The fact you have to make sure that you took out the greatest one, so you look at what is left and decide whether there's something else remaining that's common to both, and there isn't. So I know I've got the biggest one.
Right.
Okay, the greatest common factor.
And then to make sure you haven't done some wrong arithmetic.
Okay,
or you want to do
multiplication.
your...
Okay, 7 times 2a would give me 14a, and minus 7 times 1 would give me the 7, and that's my original.
What you might want to do now is do one without me giving any hints or agreeing with your common factor. And on the same page, if you would just copy the problem of 24 minus 16y I won't talk through it, so you just work along, and in about a minute or so, we'll talk over it again. But you don't have to look up or anything. Just work at your own speed.
And that was 24 minus 16y?
Right.
Okay. Okay, I think I have it.
Okay, let's look at what's on your paper then. The original problem was 24 minus 16y, and I see that you jumped at the common factor of 2, which is a very natural tendency. When you notice something
They were both even. Yeah.
Right, you take out the 2, your division was correct, 12 would be your first term, subtracting, 8y would be your second. But then I hope what you did, and I was watching you, you did compare those two again, and when you saw the 12 and the 8...
I thought of 4.
Right.
Yeah.
And then if you remembered, how did you decide to get the 8?
Well, the 4 factor that was still left here, and the 2 I already had, that would be 2 factors, the 4 and the 2, which would give me a factor of
when
the 8.
You multiply, you get 8. Then 8 divides 24 3 times, subtracting 8 divides 16y 2y times. Did you check it by the distributive?
Yeah, I just did it in my head. I multiplied back and checked up. Again, you probably say the best thing would be to probably cover
Well, after you saw that the 3 and the 2y had nothing in common and that you had gone up to the largest common factor, it really is worth the time. And sometimes just cover it with your hand.
Okay.
Because I know on a desk you're not going to want to keep flipping papers around.
Okay.
8 times 3 is 24, subtracting 8 times 2y is 16y. Because if you don't have a comparison, you're liable to force it. It happens quite a few times. What I'd like to do now is make a point, but make it by sort of presenting you with a trick question. And if you just look at the question and sort of think,
Okay.
it's not going to be any new idea until we get down to the answer. So you have an expression that's primarily addition, 2a plus 15, and let's think about factoring it. Can you find a common factor for the 2a and the 15?
Nothing divides the 2 and a 15.
If I were to write a 1 here, and you know it's multiplication, do you think you could find an answer for these 2 blanks that would check?
Yeah, well, 1 divides anything.
Right, so 2a divided by 1 for the first position would
They
be...
give me 2a.
And 15 divided by 1 for the second position.
Just 15 again.
Would you say that that was factor because there's a multiplication showing?
Yeah. 1 times the quantity 2a plus 15.
But do you feel that that's taken you a step forward, given you a simpler expression to work with?
No, what you've actually done is made it more complicated looking to me. Looks like there's more there than it was originally. And it really didn't do anything. It's the same as it started out, the second factor.
That's why if you're familiar with the word trivial, it simply means that it's not of any consequence, of any worth, and therefore any problem could always be done that way, and I've never mentioned it, and on a test you'd never be expected to do it. So I just wanted to make sure that if you saw it sometime, you'd know what to do with it. In most cases, it's simply referred to as being prime. Do you have any concept from back in the definition of numbers why we might consider this expression prime?
Like 2 is a prime number because the only things that will divide it evenly are 1 and 2 itself.
Right, so the definition of prime is something that has for factors only itself and 1. So therefore, this expression, you found out that the only factors we could find would be itself and 1. And since it did make it a little bit more complicated, we'll ignore it. So anytime if I ask you if there's a common factor and you can see the 1, don't mention it.
So I can say there isn't 1 and be really correct.
You're correct.
Because I know 1's not asked for.
Right.
Okay.
And if you were ever to meet it later on in a test or in a book and they describe it as prime, you know that that's what they're saying.
Okay.
I just wanted you to see that so that we didn't leave a gap in something that we were doing. What we want to do now is move on to a step that's one more complicated than what we've been doing. Just look at the problem of 2x plus 3x squared with the format that we need. And here, can you find a number that's going to divide those two terms?
Okay, 2 and 3. No number except 1, and you don't want me to talk about that one. So I just say there's nothing that divides both the 2 and the 3.
And that's why I said this is one step more difficult, because now you have to go and ask yourself, is there a variable common?
Okay, there's an x in both of them.
Right. So we say that x is a common factor. So now you have to be on the watch out for numbers as well as variables. By the division process that you were using to fill in this first blank, if I had 2x divided by x, the factor left would be?
Okay, just a factor of 2.
If I had 3x squared, I was dividing by just x. The factor remaining would be?
Okay, if I had 2 factors of x and I divide by 1, that would just leave 1 factor of x, I guess. So it would just be 3
and the 1 factor of x. Now, with the question to make sure you had the greatest, is there anything common here?
No, there's not even an x this time either.
That's right. And with the variables, that's always your check. If you've taken out the greatest common factor, the ones inside would not both contain that variable. And then again, if you wanted to check it, x times 2 would give you 2x. Adding 1x factor multiplied by 3x leaves you the 3, and x used as a factor twice.
Right.
Look at 5a plus a to the 5th.
Okay.
With our usual setup. Now ask yourself, is there a number factor that's common to both?
No.
Is there a variable factor common to both?
Okay, if I look at, there's an a in each one of them, again.
Right. So we call that the common factor.
Okay.
Dividing out, 5a divided by the a would leave you?
Just a factor of 5.
And a used as a factor 5 times divided by this a, which you understood is used as a factor only once.
Okay, so if I have 5 factors and I divide out 1, that'll leave 4 factors of a, which would be a to the 4th.
Internal check. Inside the parentheses, is there anything common?
No.
Then checking it by the multiplication, a times 5 is 5a. Adding a times a used 4 times means a has been used as a factor
5 times.
5 times. Why don't you try 7y squared minus y? And go ahead and put your own.
Okay, first the parentheses to show I'm factoring, and the operation sign, the subtraction. Okay, do I look for the numbers always
Always
first?
ask yourself that question.
Okay, well, there's 7 and really a 1y, so there's nothing that will divide both those two numbers. But there is a y in both of them, so the common factor would just be the y?
That's right.
Okay, now, if I divide out the factor of y, that'll leave me with 7, and I had 2 factors, and I divide out 1, that'll leave me with 1 factor of y.
Good.
Okay, and if I divide y into y for the second term...
That's it. Anything
like
divided by itself.
Okay, because that was like the numbers before. Y into y gives you the 1 time. So if it's exactly the same again as what I'm dividing out, the common factor, and the same as one of the terms, I'll leave a factor, just the term of 1.
Always, yes.
Okay.
Then how would you check to make sure you've gotten the largest common factor?
Okay, now there's 2 checks. First, I look inside what's left and decide whether or not there's still something I might be able to take out. Well, there's no variable in each, and the numbers are still, there's nothing will come out of both of them.
Then your
and
other
now I have to do the distributive check, and I'd want to cover this up, okay, and try to multiply, and y times 7y would be 7 and 2 factors of y minus y times 1, which would give me just the y, which is what I started with.
So make sure when you're doing these problems that you do the 2 checks, the one inside as well as the multiplication check. In your booklet, if you turn to page 3, you'll find 3 problems for you to do. And what you'd want to do now is actually hold the tape so you can work and check them, because since there are 2 checks that you're going to want to do, it's going to take you more time than it did before. So do them at your own pace. We'll be doing them here, and then check them. And when you're ready, come back. Remember, the same button will hold the tape and start the tape again. So if you're ready to work, punch the pause button right now.
Okay, I think I have them.
Then let's take a good look at your answers. For the first problem, there was no common number factor, but there was a common x. So the x out front was your common factor. After you've done the division, you check to see if there's still anything common, and there's not.
Yeah.
3 and 5 have nothing in common, and there's no variable. Therefore, the second check would be to see whether or not you've made a slight mistake somewhere.
Yeah.
So x times 3 gives you 3x, subtracting x here, 5x squared gives you 5, 1, total of
3 factors.
3 factors of x.
Which is what we started with.
So therefore, you know that your answer, which was the factored form, is correct. For the second one, again, there was no common number factor, but a was your common variable factor.
Right.
So after you divide it out, you checked it by looking inside the parentheses, and you decide, no, nothing is left common to both those terms. So again, you'd want to check, cover it up, whether or not with paper or your hand, and actually do the multiplication. A times 1 is 1a, subtracting. A times 7a cubed gives you 7. 1a factor, 3a factors, a to the 4th.
Right.
Now, if I wrote that out, and I were comparing it back to the original, would I say that those two were really the same?
Yeah, but you said the book probably wouldn't write this, although because 1 is the identity element, so 1 times a would just be an a.
Right. The book would probably have written it like this even if they had checked it.
Okay.
But I just want to make sure that you were aware that if you had written the 1A, it would mean the same thing. Oh, you caught it. That's good.
I couldn't find anything. I looked at the numbers 5 and 3, and again, the only thing I could think of was the trivial 1, which I didn't write. And then both of them didn't have a variable in it. So I said, it's prime.
Right, because for this case, we cannot break it down any simpler, and therefore we would use it just as it stands. Those are good. But now what we want to do is take that one step further. If you look at 4x cubed plus 5x squared with your setup for factoring, and you ask yourself the question about the numbers, you're going to get the same answer we've been getting. No, there's no common number factor. Is there a common variable factor?
You know, both of them have an x in them.
Okay, but this is your one step further. Sure, it's obvious that they both have x's, but be very careful to inspect the exponents. Let's just try to make this into a real-life situation. Let's say I had 3 x's, and you had the 2 x's.
Okay.
We wanted to match them 1 for 1. How long could we keep matching x's till one of us ran short?
Now you have 3.
I have 3.
And I have 2.
Right.
Okay. So we could match 1.
Right.
Then we could match again. And I only had 2, so I don't have any more.
Right. You've run out. I've still got 1 left, but we've matched 2.
Okay.
So we actually had 2 in common. So because we had 2 in common, we have to use the largest common factor. And in this case, the variable raised to an exponent will indicate the largest power that they have in common before they run out if they were to be matched. And now, if I have 4x cubed and I divide out x squared, what would be left in this first position?
The factor of 4 would still be there. And I had 3 originally, and I've divided out 2. That'll leave just one factor of x.
If I have 5x squared and I divide out x squared,
I'd leave the factor of 5. Now, if I divide out the x squared and all I had was 2 factors, it leaves no factors of x at all.
Right. And that's the important thing. Whenever you have a variable that's common to both your terms and you've taken it out, somebody's run out.
Okay.
Whenever the matching process happens like that, and you compare them and they were different to start off with, one of them in the answer is going to be without.
Okay.
Because he ran out, I had one left over. So you can tell by looking at them, they have nothing in
Right.
common, so you know you have the greatest, and then covering this and checking. You'll have 4, x, 2 factors, and this 1 factor.
Give you 3 altogether, right?
Adding x squared times 5, give you 5x squared.
Right.
And you're back to what you started with. 7, a to the 4th minus 3, a to the 7th will offer you the same chance.
Setup.
Right.
Okay, that's a setup.
First thing you want to do is ask yourself, is there a common number factor?
Not with 7 and 3.
Is there a common variable factor?
Okay, A's used in both of them.
So you know there's an A.
Okay, now what I want to know is,
What's the largest exponent?
could I set it up a different way? I didn't think of matching. I kind of thought of it as like a pool. We're both going to put in money to a pool, and the rule is we both have to put in the same amount.
In other words, each time I put in a share, you
Yeah.
put in. Okay.
Okay, so you have 4,
Right.
and I have 7. So we put in, and when we get to 4, we both put in 4.
Put in equal shares.
You don't have any more.
That's
okay?
right.
But I have some left over. In fact, I have 3 left over.
But the most in common was
We had 4 in common.
we had 4 in common. And that's how you determine it. You know, whether you want to think of it as matching or putting into a pool, is the idea the common means the same from each.
Right, okay.
Okay, now if you divide out a to the 4th from 7a to the 4th, what would be left for your first position?
Just the factor of 7.
And if you had 3a to the 7th and you divide out a to the 4th,
Okay, the factor of 3 is still there. And if I had 7 factors of A, and I divide out 4, it would just leave the 3. And that's kind of like, I had 3 left
right.
over.
I ran out, so I don't have any a shares left, but you had 3 left.
Okay.
Then by comparison inside the parentheses,
Okay.
you know it's the greatest common factor, and by the multiplication technique, that's simply 7a to the 4th, subtracting 3, a to the 4 factors, and 3 factors would be 7 factors. Why don't you try x to the 3rd minus x to the 9th? X to the 3rd, subtract x to the 9th. And make sure you get the largest.
Okay. You have 3, and I have 9.
Good.
Okay. We both have 3. Okay.
I'd run out.
And that'd leave me, because I had 9, that'd leave me with 6. So that'd be my answer.
Go ahead and do your distributive multiplication check there and see what you get back.
Okay, so x to the 3rd times x to the 6th. That's 3 factors times 6 factors, which gives you a total of 9 factors of the x, which is x to the 9th.
Something should strike your eye as being funny.
It's not what I started with.
Right, you start off with a binomial that had 2 terms. Your answer only has 1. So this is why it's always safe to cover it up and actually do your comparison.
So that's all wrong.
Well, go ahead and put your original setup for the formula.
Okay,
You know,
what I forgot, I guess, was I'm factoring, so I set up the parentheses to indicate factoring and the operation sign, so I'll make sure I'll get the 2 terms.
Right.
Okay.
And
Was
then
x to the 3rd right?
Sure, right, because we could match, or we could each put in 3 shares, and then I'd be out.
Okay. Now, if you divide out x to the 3rd and you had x to the 3rd,
Anything divided by itself
that's
is...
just 1.
Good.
Okay. And if I divide out 3 factors of x and I had 9 to begin with, that'll leave 6. And that's the one I remember getting at the top. Okay.
Then your inside comparison,
Nothing else common.
Now go ahead and check and see if it looks better
Now,
this
x to the
time.
3rd times 1, since that's the identity, will be x to the 3rd minus 3 factors of x times 6 factors of x would give you altogether 9 factors of x.
That
That's
looks
what
a
I
lot
started with.
better. Again, I think you're going to want to turn to page 4 and take a little bit more time on these.
Okay.
And you'll find 2 examples there, but they're a little bit longer. And so you'll pause the tape, work on them, check them, I hope, using the check inside the parentheses to make sure you have the largest variable factor, and then the multiplication check just to make sure your exponents and numbers have fallen in place correctly. Then when you're finished and you're ready to go over them with us, the pause button will start the tape again. So if you're ready to work, now's the time to press the pause button for the first time.
Okay, I think I'm finished.
Let's look at them together then. The first problem, you decided that the common factor was x squared, and that's good because if I had 6 and you had 2, after we both put in 2,
We both have 2 in common.
right,
Okay.
then you would have run out. Then by checking the inside, you can see that there's no common factor there, so you have the greatest common factor. To check it by the multiplication method, x squared times x to the 4th would give you x, 2x, and 4x give you 6x
Right.
factors, and the multiplication identity, x squared times 1 is going to be x squared.
Yeah, that was one of the ones where the common factor and one of the terms was identical. When you divide, you just get the 1,
Right.
and it checks back when you multiply.
Sometimes it might be in the first position,
Yeah.
but anytime one of the terms is identical with the greatest common factor, you'll always have a 1 inside your parentheses. That's a good thing to notice. The last one, x to the 3rd, is the greatest common factor because although you'd have 2 left, we could
Right.
have only matched or put in 3 equal shares. Then you divide it out to get your second factor, and inside the parentheses, you notice that they have nothing in common.
No. So I knew I had the greatest one that time. Took out a
And
nut.
so by your multiplication check, and I forgot last time, but make sure you try to cover it by whatever method.
Okay.
Multiplying, you get 5x cubed. Subtracting, this will give you x. 3 factors multiplied by 2 factors give you 5 factors.
Right.
So what we've done so far is we've taken each individual step.
Right.
And so you've learned all the individual steps, but what we haven't done is put it all together. We've done numbers separately and variables separately, but in the problems you're going to run into in this context, in other mathematics courses, or in science courses, you're going to need the technique or just the practice of having done the numbers and the variables together. So although you might be comfortable with this, remember, there is a tape for block 3. It's short, but it's going to put all these concepts together. So I don't know whether you noticed, your booklet had a page 5 in it.
Yeah.
And so page 5 will give you the opportunity to do a few more of these separate ones on your own, and the answers are right in the booklet. But then if you've got those separate concepts, and you want to put them all together, you'd want to take the tape for block 3 and listen to that.
Yeah. I think I'm going to practice not only the ones on the last page, but I want to re-practice some of these. Like, what I'm going to do, just copy them down.
Right.
Because I've got the answers now.
You copy the questions on your own paper and then put this away until you've done them. Then you have an automatic check.
Because I'm going to feel much more comfortable after I practice more of these, because this is a lot more difficult than the last one.
We have to keep assuring yourself not only is there confidence.